do that. And it is. Good. And I will briefly share the nice slide that Talia put together.
Oh, look at that.
And I will put the URL to these notes in the chat. I can figure out how to do that.
Ooh, nice. I'd see it still says, it still says PST. No, this is PDT. PST is an hour from now, but yes.
Oh, yeah.
But that's okay.
So that's a lie.
That's a lie.
Yeah.
Well, I do appreciate all the rest of you figuring out what time it's supposed to start when it's not listed in your time zone. It is a great convenience to me on this occasion to have it be in my time zone, so I know when to be here.
I don't know how aware you are, Asla and Jimma, but Tim and I have known each other since 1984, Tim?
Approximately.
Approximately since 1984. We have done many things together, including writing a book and playing chamber music and many NSF-funded projects over the years. Though Tim has avoided being an employee, he has. We have managed to work together on Fathom and data games and CODAP and data science games, and I'm leaving out things, but Tim was definitely a co-designer of Fathom and has been important in the design of CODAP. And I guess we're now thinking together quite a bit about data science and data science education and what should be happening with that. And I think that's what you're going to talk to us about today.
That's exactly right. Yay. Someone else looks like they're trying to join. Joachim. Okay, we don't need to introduce us to him.
He's already very familiar with us.
Joachim is familiar with us. Okay,
and he's from Germany.
He's from, right. Can you hear us, Joachim? For we cannot see you.
Okay.
You will see.
Can you hear me?
We can hear you.
Okay. This is enough. I'm sick. I'm in bed. So I'm no pleasure to look at.
Okay. All right. Well, another time we will see your lovely face.
Oh, let me just say one thing. Since we're all present here, you can interrupt and there's very few of us, you can interrupt audibly just by speaking out when you have a question for Tim, or you can raise your hand if you're visible.
Okay, very good.
Okay. Now, you should have found, and I don't know, let's make sure we've all found.
Well, let me paste that in for Joachim.
Okay. So in the chat window, the rest of you should have seen this little shortened URL, short.concord.org/48. Yes? Do you see that?
Yep.
Okay. And so here's the plan. We are going to, I'm gonna make this, I'm gonna exit full screen for myself so I can see the rest of my screen. I am going to, let's see, I'm gonna share, oh look, there's a bunch of people here. I'm going to share my screen. We can see you walking now. Come on. We're gonna share my whole desktop. And now, okay, and so you should be able to see this screen now on my screen. Yes?
Yes.
Signify by going like this or going like that. Excellent. And Dean is coming in. Great. So what I would like to do is begin with some refamiliarization of ourselves with CODAP and some work to make sure we're all kind of on the same page. And for that, you can see it says we are here. And what we're going to do is, first of all, we're going to go to this document, NHANES age 5 to 19 aggregate data. And I'm going to do this right now so you can see it. Actually, I'm not going to do it. Oops, undo. I'm going to go to what it will look like when you open it. So it will look like this when you open it. And your goal is to, actually, maybe it won't look like that. We'll find out whether it really does. It will look like this when you open it. And your goal is to play around and make a graph or something for just briefly. And then we're going to, let's see, we're going to play around. We're going to use this thing that I learned from Holly Lynn in the last webinar, which is a Padlet. And I thought they were really sweet, and I've never used them before, and so we will use them extensively today. And when you open this Padlet down in this part, Padlet for data file A, I'm going to identify the parts of this webinar by letter. Okay, so we're in part A, right? And when you get to the Padlet for part A, it will look like this. And what I would love for you to do is to, as you make your graphs, you're going to have to go back and forth between the different tabs of your browser. And we'll assume we know how to do that. And you're going to be looking at this data and maybe playing around and making some graphs and deciding what you can see, and then adding little posts with the plus signs to the Padlet here. And you can see a number of different questions. So Dean, can you hear me?
Yes.
Great. Do you have this document here?
Yes, I do.
Excellent. All right. Great. So let's just spend a couple minutes playing with this, and I will also play. And if you have any questions at all, like, what do I do? Just ask, and I will help you out. And I will see if I can tell from your faces whether you're actually playing. And we can't see you, so if you want to be seen, you will have to start your video. If you do not want to be seen, that's fine too. Stay there, I'm going to leave that one. So I'm here, I'm looking at mine, and I say, I want to make a graph. There they are. Look at that.
Boy, that's a weird graph. I wish we could see everybody's screen at once.
I wish we could too. There are ways of doing this, but. I can't drag index in. Over here, the Padlet.
It's so weird.
And I'm kind of evaluating how done we are by looking to see whether people have done things here.
Wow. I really am coming to like this graph.
Ooh. Okay, so you can, looks like you can actually paste graphics in there.
Really?
That's what I've done a lot. So I use Padlet a lot with teachers when we do professional development. And so one of the things that Holly Lynn and I a lot of times have them do is we have them actually post a graphic of their graphical display. Because like you were saying, you want to kind of, it would be nice to see everybody's at the same time. And then sometimes you can move them around too. So you can show different representations when people are trying to show the same thing, which is kind of nice.
Yeah, I hadn't tried that since I'm a Padlet neophyte, so this is great.
Yeah.
So how did you make the screenshot?
So I did it, I just used the screenshot feature in CodeUp, but I've done it with screen grab too, like, you know, just taking the picture. But basically I just did this, I used the screenshot feature or the picture feature in CodeUp and just saved it to my Google Drive. And then when I was actually typing, I selected like attachment, and then it asks you where you want to get the picture.
Oh, look at that. Yeah, okay. So there's add an attachment. Great.
I just pasted.
Oh.
And
Well,
it asked me which column.
That's
it asked
probably
me which
easier.
column to paste it in, and I said, put it in that first column there.
Okay.
Oh, yeah. Yeah.
Great. Great. Okay, good. So, and it's Gemma, is that right?
Gima, yes.
Gemma.
Yes.
Okay. How do you spell that?
Gemma.
That's right. We spoke about this before because most people would think it was Gemma.
It is. In the Philippines, it's Gemma, but my parents decided to change it for whatever reason.
Okay, that's fine. See, if I write it this way with the macron over the E, maybe I will get it right. We'll see. Wonderful, thank you. Yeah, so notice the age at which height diverges between men and women.
Can I ask a question?
Sure.
You hear me? Did I miss getting the file that gives me access to the CodeUp Cloud?
In your
I
chat,
only see your screen and the Zoom window.
so in the chat part of the Zoom window,
The chat part.
down below,
Where is the chat part?
there's a button down below that says chat. If you move your mouse
Yeah.
and click on that.
And okay.
And then you click on short.concord.org/48. And that will take you to Tim's Google Doc. And we are looking at the very first N. Haynes.
Haynes age is 5 to 19.
Yes.
I see the document, but okay. So what if I click on N. Haynes age 5 to 19? Nothing really happens.
Well, click once, a panel opens up right below it with a longer URL.
And Tim is demonstrating that.
Click on that. You might not be showing the Zoom window right now. Can you see what I'm doing, Joachim?
No. Sorry that I'm.
That's okay.
Yeah.
It's possible you have never done this particular move before.
Yeah.
You need to learn this.
Right.
So, are you looking at the Zoom window now so you can see me?
Okay, now let me see.
My
What
screen?
happens now? Now I got a Google document.
Yes.
And a CodeUp file opens.
Okay.
Wow. Yeah, I am.
And it will look something like this, except it won't have a graph yet.
Oh.
How do I get back to you folks?
Probably Alt-Tab will take you back. and forth.
Okay.
Okay, at least I can make graphs as suggested.
Oh, updated us. Yeah. Well, I'm not able to paste something in. This is, come on, let me paste. Nope, it won't do it. Oh well. Cool. Yeah. Okay. So Joachim, can you make a graph and things now?
I can make a graph, and yeah, but I cannot get back to your Zoom window.
Ah. Well,
So sorry for keeping you up.
that's
You,
all right.
you can tutor me in 6 weeks in how to efficiently.
Try Alt-Tab.
Alt-Tab. No.
Okay.
Ah, here I am. It was the Command tab.
Oh, you're on a Mac. I forgot.
Yeah.
Right. We're trying to translate to Windows for you, and
Okay, good.
yes, Clover tab, as we sometimes say. Okay, I now see somebody else's
Yeah,
graph showing up
that's
here.
mine. Sorry, I didn't put the title.
That's all right.
I was struggling with, I wasn't listening the Jima's answer, how to import the graphs directly from the CodeUp. So I've used my own way on Mac, Control-Shift-4, take the screenshot and post it there.
And I tried to do a screenshot and it would not paste. So with my screenshot utility that I use all the time.
Yeah.
Did it paste for you, Jima?
It does. I mean, I find that sometimes also I actually prefer to do what you did because it doesn't have as much white space. Sometimes I feel like when I use the CODAP function where I use the picture, sometimes I feel like then there's too much white space. But yeah, I could do it both ways.
So when I click on the camera on CodeUp, it's asking me export file as Google Drive or local file.
You just have to tell it where to save it. Either you want to save it on your hard drive or you want to save it in your Google Drive, which is one of the nice things about CodeUp, right? That you can save it in the Google Drive. You don't have to save it on your hard drive.
All right.
So interesting. I want to click on the points in your graph, Jima. But I can't. It's just a picture.
It is just a picture.
All right, so I'm going to save. So I'm going to see if I can make my graph appear because I want to use it as a demonstration here.
Yeah.
Let's see, if I do this and I go to, I have to move all the various things, choose file. Nice, I want to go to webinar, aggregates.ping. Looks good. Okay, there we go. Okay, so now we have one from me. Okay, so let us move on. And I want to just take a little look at the things we have in front of us here. And you are, I hope, are on the Zoom window right now, or you can just listen to me. But I'm looking at the Padlet. And so we see a bunch of different graphs that people have submitted, which is fun to see the graphs. It's kind of too bad we have to scroll all the way down in order to see them all, but that's okay, we can handle it. What could you use a graph for? Noticing the age at which height diverges between men and women? Yeah. And wondering, are the relationships the same, and how would you describe those relationships? And another thing I might have used it for when my child was growing up is trying to tell whether my height is anywhere near normal. You know, and that's another good question. And that links to this thing over here. What other data about these kids do you want to see? Variation. Well, if we're statistics teachers, variability is one of the things we're really interested in. And if I want to know how normal I am, I might not be interested just in the mean, but also in the spread. And so this data set only gives us the means, and so it doesn't give us any information about the spread. So that's additional stuff we might want to find out. And we brought some prior knowledge to bear, like how to drive CODAP and using CODAP. And I have some other things that I wrote here. And so anyway, that just gives us a little refresher about using CODAP and about using Padlets. But also, it's an example of the kind of thing that you might see in a school if people were trying to, you know, we say, let's give kids some data that might be really interesting to them. Let's look at the heights of students of different ages and they can see where they are. And I claim that this is not what data science is about. And so if we're trying to do things about data science education, we have this problem. We have to figure out something about what data science is and what data science education is. And that's the topic, the main topic of this webinar. And so I'm now going to arabesque into an actual slideshow because I have a bunch of visuals prepared. And we'll go over here and I'm going to start to play this slideshow and we'll say, oh yeah, it's about data science education. And this is a situation in which very often, in fact, it might be always when you're trying to do data science education, whatever it is, and I'm going to claim that nobody really knows what data science is, where students are using technology with data. And, or actually, I'm going to back up one. There's data science, and no one knows what it is, but it's becoming important, even though we don't know what it is. And so, as educators, we must be interested in data science education. It would be a good idea for us to think about what data science education would look like. And I think that data science education must have at least 3 different components. One is students actually using technology with data in some form or another. Another is that maybe students would use what I'm going to call data science products. And so you go to the New York Times site and they have a bunch of really cool dynamic visualizations about some interesting data. Maybe it's important that students learn to use those and answer questions and ask questions about things like that. But I think it's also important that students, if we can figure out how, that students actually do data science, whatever that means for students. And that is what I'm going to focus on here. These other things might be important, but I'm interested in exploring what is it that we can have students do that, and for lack of a better word, smell like data science. We're pretty sure they will not be able to do giant machine learning things with huge data sets, especially not at middle grades or high school grades, at least not right now. But what can they do that will get them ready for that sort of thing? So here are some other notes before we begin. First of all, everything we're going to be doing is going to be descriptive rather than inferential. In statistics, we really push towards doing inferential things. We're not going to touch it. And a lot of data science doesn't touch it. And there's this tendency when we're being stats educators to think, oh, well, the descriptive part, that's the 2 days at the beginning of the semester, and then we're going to go on to do the real work. And I think that would be a mistake. And that there's a whole bunch of descriptive stuff that we can now do that's every bit as interesting and intellectually challenging and problematic as the inferential stuff that we've been teaching. And the thing I'm also particularly interested in is what can we do before coding? A lot of what people talk about in data science out in the world doing data science, I will call these the big dogs of data science. The big dogs talk about coding and they want to code. And I want to find out what we can do before coding because I'm afraid of, well, it's coming up here. So we'll come back to that. I think there's a naming problem with data science. calling it data science has always troubled me, partly because I can't see what, as a science person, what's the science? I mean, we aren't developing hypotheses and testing the hypotheses in order to see whether they make sense. And so I can understand wanting to call it data science. It sounds great, but I kind of wish we had a different term for it. I probably don't have the leverage to change it, but I'd like us to think about that. And finally, I think there's an equity problem. Because the things that we're going to do in data science have to do a lot with technology and with comfort around data, I think we run the risk of marginalizing some communities if we don't figure out how to include everybody in using technology with data in interesting ways. And I think that's another example, an aspect of wanting to do things without coding. If we do a course, like imagine the upper division data science course, and the first day of that course, the professor will say something like, everybody, I want you to go out and download Jupyter Notebook and make sure it's installed on your computers, and make sure you've done the first couple tutorials and learning to program in Python, because we're going to be going beyond that in order to use a couple different Python libraries. There are a lot of students, if they haven't already coded for 5,000 hours, they're going to be frightened and they might be turned off. And we want to jumpstart people getting in. And the spirit of, say, advanced placement computer science principles is a great spirit for trying to address this equity problem. And I want to see how we can do it in data. Okay, onward. So I mentioned that something that smells like data science, and I'm gonna claim that we can recognize data science when we see it or when we smell it. Some things reek of data science, like Google searches, right? They're data science. Getting a route for your car from your phone when you're just driving around. A recommendation engine. Netflix tells you what you might want to like. That's kind of astounding. And there are cool visualizations. Let's see a couple of them. Here is Uber data for pickups in San Francisco. Oh my God, look at that. Here's world trade on this cool visualization showing who's trading with whom. Yeah, I'm here in Oakland, California. Here's a week's worth of crimes with the kind of crime color-coded and their locations. And here are, from the 1940s to the present, the prevalence of names beginning with MAX, right? There's all of this data, and you can ask questions and things like that. So here's all this stuff. And I claim that this smells a lot like data science. But what is it? What is it really? So this is a diagram from a guy named Drew Conway. And wow.
Oh,
That sounded vaguely Baroque, okay. And when people try to define things, oftentimes they either use a cycle or a Venn diagram. And Drew used a Venn diagram for data science, and Bill has used this Venn diagram also. And you can see that it has three main areas. It has math and statistics knowledge, sort of content expertise, and this thing that he called hacking skills, but we might also call computational thinking. And he's done some nice things here saying, oh, here's where machine learning is. I love it that he calls this the danger zone, when you know a lot about an area and you apply computers to it, but you don't use any mathematics and statistics knowledge. What can possibly go wrong? Lots. And here's where traditional research has been without the aid of a lot of computers. And I think this is where we spend a lot of time. So I'm going to circle this and say, this is where, if we try to use data, up until now, if we tried to use data in a content area in school, we've kind of been in that area. And what we want to do, oh yeah, so, and this area means there's not substantial tech skills involved. And what we want to do is we want to move there. And so we want to know, how do we get to data science? And I claim the journey to data science, based on this Venn, is from this area into there. So we want to cross this little arc and make it into the computational skills circle. However, the Venn for me is not enough. It doesn't help me identify what are the things I think kids ought to do. And so what I think we need to do is develop a data science sniff test, okay? And so what should be in our sniff test? And so in our project, which is called Data Science Games, and this is not about that, but you can imagine we've now spent almost 2 years trying to design games, and they use CODAP, and they're trying to help students do data sciencey things. And as we've been doing it, we've been trying to notice what are the things that characterize it as data science as opposed to something else. And there are 3 main areas. And I should say that if you want to get these slides, they're on the page, you can download them. So don't worry about notes and stuff like that. So for one thing, when we feel like we're doing data science, we've found that we feel like we are, and for lack of a better term, Bill used this, and I think it's actually a great term, that we are awash in data. All around us, or we're in the ocean and we just got hit by a data wave and we're tumbling around and we're not quite sure which way is up at first. There's this sense that data is, there's kind of maybe too much of it or something like that. Another is we discover that in order to accomplish what we need to do, we do stuff that we have tentatively called data moves. And data moves we're going to talk about actually a great deal. And one of my main goals in this webinar is to use data moves, and so we can try to talk about whether they really feel like they're data moves or not, without defining them completely, but we'll come up to a little bit of that shortly. And the other is that the data themselves might have particular properties that are different from the properties of usual school data. So let's look at each of these ideas in sequence. So awash in data. Okay, so one characteristic of awash in data is that you have a chance of getting confused. I'll try to go through these pretty quickly. Another is that your path to a solution might not be obvious. And you're often looking for order in chaos, the signal and noise. You're looking for a needle in a haystack, stuff like that. And finally, if you're awash in data, it's ready for creativity and ingenuity. And if we think about what we just did with the data about mean heights, it was interesting data, but there's not too many different graphs you can make. There are a few. And if there are some questions you have, it's not very hard to figure out how to use the data that's there to answer those questions if they're answerable. Next slide. Data moves. And here's something that I think might be true. If you see somebody doing these things, it's good evidence that they understand something important about data. In the previous, with the means data, if a student puts something on one axis and something on another axis, they may just understand about how to make a graph and what it is they're trying to do. There's no particular data thing that they know. So let's look at some examples. To make a new or unusual visualization, like the one we're seeing here, or you might use a graph in order to focus your investigation, or you might use grouping to compare, or you might have to invent some kind of measure that doesn't exist before. You might make stand-ins to represent something that you don't have data for. You might make some sort of calculation. You might slice the data or filter it, and we'll do a lot of this today. You might reorganize the data, and we're going to do this also. You might transform the data. Imagine you have a data where the columns are what you really want for values. And so in a way you want to take the table and go like that with it. Or you might want to relate the data to another data set. And so relational data is another example of something that might require a data move. And most of these things, you have to have technology, or it really helps to have technology in order to do effectively. So finally, data properties. Very often the data, when we feel like it's data science, it's usually greater than 2 or much greater than 2 variables. It's a fairly large data set, and by that I mean maybe more than a couple hundred data points. And there might be a non-obvious organization, like it might not be flat. So if I look at all these things, let's see if there's another one or whether we're going to the next slide. Oh, it might be unruly. There might be missing things, stuff might not be in quite the order that you need. It might require wrangling. And I should say that data wrangling is something that many people think is part of data science. I agree. And we are not going to talk about data wrangling today. I think that's another topic. Okay, so let us move on. Oh, it might even be spatial. Yeah, spatial data is something that in this traditional statistics class we haven't touched. And it's becoming increasingly important. So like this Uber data, like you see on the screen right now, how do you deal with stuff that comes with addresses, with latitudes and longitudes? Okay, so if we look at this, if I look at this and I do this sniff test, I say, are we awash in data? Well, no, not really. There's good data, it's worth looking at, but I'm not feeling very confused by it. Are there data moves? Well, we made a graph and I did color this one by whether they were female and male. I think that coloring it might be a little bit of a data move because I'm making this visualization and I'm using it in order to communicate a little bit better. And it's not necessarily something that would traditionally be taught. But there's not a lot of data moves going on. The data properties, is it big? No. Is it very multivariate? No, there weren't very many variables. So I find this doesn't smell like data science to me. And we use a computer, but it doesn't seem like computational thinking to me, as we're also trying to define computational thinking. So I don't think we made it over that arc into the other circle. Let's see what's on the next slide. So, but if I use a sniff test on things like this, I can see that, oh, like I love this one here in the middle. We might see a graph very much like this. And I look at it and I think, oh my God, what is going on in this graph? I can't figure it out. It's formidable. All right. Is it wash in data? Yes. Data moves? Yeah, we're going to have to. We'll see it. Data properties? Yeah, lots of cases, lots of variables, you bet. All these are from the same data set, by the way. And so now let's consider, what does the raw data look like that's behind this graph? So somebody tell me, what does the raw data look like that's behind this graph?
I would hope it would be individual kids.
What would you get about each individual kid in order to make this graph?
The survey forms?
Yeah, so maybe there's a survey form, and what would be on that survey form?
Their age and height.
Yeah, so you need their age and their height.
Or their gender.
And their sex, right? Gender or sex, yeah. So there are these things that you need. And then we would have to do some kind of processing in order to get this graph, right? We'd have to like group them by age and by sex, and we'd have to compute the mean. And we'd have to organize all those means into the table that we got in order to make this graph. Okay, now, frequently, we don't have kids do that. We give them this graph rather than what we're going to call the microdata, the data about the individual kids. And so what we're going to do next is we're going to get the data about the individual kids and explore what it's like working with that. And then I will lead you through how to make this graph using CODAP with the individual kids data. And our goal will be, how do we know, or does what we're doing feel like what we might call a data move? And so I want to now move back to this page. And I'm gonna take this, we are here, and I'm gonna put it here. Okay. Actually, I could put it at the beginning, huh? Let's do that. There, we are here. And so let's everyone open up the NHANES ages 5 through 19, 3,248 cases. And you will see something that looks like this. And I'm going to look at my notes and see where I am. And we're here. And the first thing I'd like you to do is we're just going to spend a couple minutes exploring. And this is a very, I've removed lots and lots of attributes so that there are only a few attributes present. And I would love for you to play around with this. You can make a graph. And when you first see this graph, you will see CODAP filling it. What it's doing is it's filling it with all 3,248 points, but we haven't organized it yet. So let's give everybody a few minutes to play with this, and then I will show you some stuff about it.
Is there a Padlet you want us to play with or not?
No, I just want you to explore the data for now, and then I'm going to lead you through making that other graph.
Okay. I guess we can assume that weight is in kilograms?
Weight is in kilograms. I'm sorry, I had this actually in, I had the units in there before, and I somehow must have connected to one without the units. So I apologize. Height is in centimeters, weight is in kilograms, yes. And of course, there is a Padlet for this. And actually, we have few enough people, you can probably just tell me, like, what kinds of graphs are you making?
I can't make a graph. Keep popping the cases. It's too much.
So, Asla, what kind of graph are you trying to make?
I just delete some attributes. I just kept gender, age, and height.
Oh, okay.
But as there are too many cases, like 3,248, yeah, it just now stopped. I can't do a graph.
What browser are you using, Asla?
I'm sorry?
What browser are you using?
Firefox.
Do you have Chrome?
Yes, I do.
Try it again in Chrome. I think you'll have better luck.
Okay.
And
Takes
Gina,
all this time. All right, I'll do that.
what are you making? Ooh.
Well,
High data. Yay. So Gina, what have you been doing?
So I think I did something wrong. So I was trying to make the graph that you showed us instead of looking at individual cases.
Uh-huh.
So I made a hierarchy with the table and then tried to, so then I basically, I put it in the Padlet, but I started by like just graphing the heights, but then I was thinking we were supposed to be graphing the mean heights. And so then I created a hierarchy, and I don't know if I had to do that, but I pulled out the sex and the age and then used a formula to find the mean heights.
Great.
Graph the mean heights on the x-axis and the ages on the y.
Looks pretty good to me.
Oddly, I'm not seeing it in the Padlet. But
It's,
oh, no,
yeah.
I see it. Yes. Okay.
Yeah, so I started out by just graphing the heights, and then I put the ages on the left, but then realized, oh, I just have distributions of all the heights instead of the means of the heights.
Right. Good.
Yeah.
Yeah. So you have completely anticipated everything I'm going to do later.
Well, that's why I was saying I think I did something wrong.
No. It's splendid. And how about you, Asla?
I
Is it
got
looking better?
a distribution of ages.
Ooh.
That's all, I guess. Okay, I'll try to do the snapshot of it. Let me see if I can transfer it to Padlet. You see that?
And Joachim, how are you doing?
I succeeded in reproducing your graph, and now I'm playing around a bit, investigating relations between height and weight and race and sex and body mass index.
Okay. Good. All right. And you were going to tell us something, Asla.
If I can get my graph here. Okay, I'm going to go back and do it in the
Oh, there's something. There's Gina's original. Great. Yes. Cool.
How I can make my products visible to you?
If you use the Padlets. Is that on the, let's see. Can you see my screen right now where it says, okay.
With the green background. Yeah.
Yes, excellent. And you get to that in your own browser. And now I'm going to switch to the outline.
Okay. That's what I.
See down here under links to discussion forum data.
Okay.
Padlet for file B and Haynes microdata.
Okay.
And you can paste, now I'm going to go back to the Padlet, which is here. Suppose I want to add something, I click this plus sign, and I can add a title or some text, and if I want, I can add an attachment of various kinds. I'm not sure what that one is. Yeah, okay, I can add a video or audio or a picture, or I can add a file. And some people have had luck pasting in screenshots. So that is how Jima did her two graphs.
I've been unable to do it since then.
Okay, and so if you save, if you use the, and now I'm going to go back over to CODAP. For example, here's a graph of mine. I can use the photograph icon to save a file. I'm going to save this file, and I say, oh, I could do it here on Google Drive, or I could make a local file, and I'll download it. And I'm going to put it in some folder that I recognize. Now I'm going to go over here, and I will add a picture. And I'm going to say, choose a file. And there it is, the micro ping. And it's uploading it, uploading it, uploading it. Trying to decide whether it likes it. Looks good, yes. And now it should appear. And so it does appear down here. Okay, and now someone has posted a distribution of ages.
Yeah, that's me.
Great, okay. So we've learned here, interestingly, that the people who did this survey sampled teenagers more than they sampled younger students or younger children.
Yeah.
Now here in mine, what I did was I put age on the horizontal axis and height on the vertical axis, which is kind of what Jima has here, only sideways, except that I did one more thing. And just so that you know that this is possible, I changed age to be categorical so that I have separate parallel dot plots. I can change it back. Now I have to move my, I've got my Zoom thing in the wrong place again. I'll put it way up here. I can say treat as numeric, which is the way it is by default. And now they're all lined up because the ages are integers. And so the coordinate of each point is a whole number. But if I want to separate these into different groups, I can treat it as categorical. And what I see here is I have sort of yellow for female and purple for male. And it looks like up until about age 13, they're pretty much mixed up. And older than that, there's more purple at the top and more yellow at the bottom, which also fits with the data that we saw before, except that it includes all the variability, which is kind of fun. But in case you didn't know how Jima did what she did, I want to step you through that because I think it's an important data move. And actually, before we do that, I want to just look at, I want to do a filtering operation. And so what I'd like to do is look just at 10-year-olds. And if you have not, I mean, most of you have done this in CODAP so much, I'll just do it so you see. I'm going to select all the 10-year-olds. They're all selected. I go to the eyeball menu. Is it going to let me do it, or is it See, now everybody's in the wrong place. So go to the eyeball menu and choose. Come on, eyeball menu. All right, hide unselected cases. And so now I have just the 10-year-olds. At this point, I can split these by sex. And before I do, who's taller, 10-year-old girls or 10-year-old boys? What do you think?
10-year-old boys.
Well, let's find out.
Or is it-
Okay, so now I see a split dot plot, and I'm going to put the mean on here. Wow. The girls are substantially taller than the boys at age 10. And if you spent much time in middle schools lately, you know that there are so many, or the ninth graders at age about 12 or 13 in high school, the little boys, they're so cute, they're so shrimpy, and the girls have gotten all tall. And there's this time when the girls are the tall ones in the class, and this is one of them, like 10, 11, 12. And so we might want to say, if we notice this with just this age, how does the difference change over time? And so that's one of the reasons why we might want to find the average by sex. So let's do that. We're going to do exactly what Jima was talking about and say, you know, if I want to find so what we've seen here is I grouped these by sex this way. We're going to group them by sex using the table now, because I want the table to be different. And so I'm going to do calculations about females and males, but not just females and males, also about every individual age. And so now I have in my table sort of parent collections, so that if I click here, I will see only the 19-year-old males. And if I click here, I will see only the 5-year-old females. If this table bugs you because they're not in order, it is now possible in CODAP to sort. And so I click here on age and I get a menu and say sort ascending. And now all my ages are sorted, which is great. And I can still use these. Like I can take age and I can put it on the horizontal axis. And now I have only 10s, right? And I can put sex on the vertical axis, for example, and see what happens. And I see, oh, wow, here are a bunch of the different ages that are possible and the different sexes that are possible. But what I would really like to have is the mean of the height. And so I'm going to create a new column. And I could create it with the plus sign. I could create it here, or I could create it here. But I want it at this level. I want one number for every age-sex combination. So I click plus, and I'm going to do exactly what Jima did. I'm going to call it mean HT. And I can look here. I can edit its properties. I can sort it. Oh, but I can edit a formula. I start typing mean, and I see, wow, look, I have mean, and I start typing height. Ooh, height is one of my attributes, so I can choose it, and I apply it, and now I have the heights. So I could put the height on the vertical axis, and now we have the graph that we had before. I've transposed the axes from the way that Jima has them, because I have age on the horizontal axis. You could do it either way. I think of age as more of a predictor variable and height as the response. But of course, with kids who are just learning this, you can do it either way. And now I have this graph, and it's great. I once again do not have the variability. I wonder, let's see, suppose I made another column and I called it minimum height. Does CODAP have a formula for minimum? Oh, min. Min of height. And I'll apply that. And now I can see the minimum height, and I'm going to put this on the same axis. Okay, so now I have the minimum height for everybody, and I could put in the maximum height And wouldn't it be great if we could have it make a bar between them, but we can't at this point. But you can see that there are ways that we might be able to create new and different visualizations of the data that might even account somewhat for the variability we might have been interested in. So let's see. We split it by sex. I'm going to reorganization, create new attributes. Okay.
Are there questions?
Yeah. Anybody got questions?
I just post one. How did you get the second table? I follow you through, but I did not understand. Which button did you push for the second table?
The second table?
Yeah.
This one here?
Yes, yes, yes.
Oh, okay. What I did, so now I'm going to go back. I'm going to create a fresh one of these. Okay, so here's my original table.
Okay.
Okay, and I'm saying I want to separate this table out by sex, for example.
Mm-hmm.
I can grab the sex attribute and drag it to the left. I'm dragging it to the left, and here there is a sort of a yellow rectangle, and it says drop attribute to create new. And if there was more room, it would say collection. And I do this, and now what I have, since you are colleagues of Jima, I thought that you both knew all of these things. This is great.
I'm pretty new. This is my first time using CodeUp.
Oh, it is? Okay, great. So I'm gonna click these little minus signs so that it goes away completely. And it says, oh, wow, in female, I have 1,631 cases. In male, I have
From
16.
there on, it's easy.
Okay, good. That is,
realize how to create that.
this is a subtable, and this is a sort of a parent table.
Yeah.
But I can drag any attribute I want in there. And if I want the sex and the age to be together, I can now do this, and every group is by sex and age.
Okay.
If I wanted, I could make another layer of this hierarchy and move sex higher and say, oh, for every sex, I have 15 ages. And for each one of those ages, now I can't quite get this, like here are now the 10-year-old females. For every one of those ages, I have a certain number of individual kids.
Okay.
And one of the things I think about this.
I've used Fathom and Tinkerplots before.
Yeah, good.
I don't think this feature was available in any of them.
That's right.
Correct.
This is brand new.
Thank you.
And I think that this feature in particular leads us to some interesting computational thinking. Because we're actually having to think about the organization of the data and what is superordinate and what is subordinate. And we can change which one is which. And the way we change it depends on what we're trying to find out about the data. So if I just want to know whether males are taller than females, I can put the mean height here. But if I want to know whether 17-year-olds are taller than 10-year-olds, I might completely reorganize this table and have age be the primary thing.
Yeah. Okay, thank you. Thank you. That was helpful.
Good. Great. Well, thanks for asking. That's great. So let me give, okay, here we go. Question is, how much are we going to get through here? I'd like to give you, and so again, very quick, let's do this next one actually quickly. We thought we were going to do some of the other ones quickly, and it wasn't as quickly. This one we'll actually do quickly. I'm going to open up part C. We've lost our two other guys.
Joachim says, thanks for the instruction, Tim. I learned a bit more about CODAP. I have to leave here. Meet you soon in Hungary, he says.
Okay, that's good. I will be meeting him in Szeged, the home of paprika. So I'm going to open up this one, which is called ACS ages 25 to 44. It's part C. And here I have 1,000 people who are ages 25 to 44. And what we have for them is their sex, age, marital status, race, what Hispanic group they're in, if they're in a Hispanic group, what their employment status is, how much education they've had, and interestingly, their total income. And so, and there's a Padlet to go with this, of course, in case we had so many people that we couldn't get participation easily. But your task is what seems to affect income more, race, education, or sex? And this is also a time when, if you felt like you needed a couple minutes to take a bathroom break or something like that, this is a perfect time to do it. We will not spend very long in this, but you might be able to quickly get some answers for yourself.
So, oh, first income. Income.
Well, this is something Bill has to see. Okay, Bill, here's something I want to show you. Oh, he's going to put in his ears. Okay, Bill, here's something I want to show you. Welcome back.
Yeah.
Okay, so I kept it so that education was in order. But when I put it in the table, it's no longer in order. Oh, maybe if I just sort? No. If I sort it there? No, that's doing it.
Yeah, I don't think, unfortunately, that the table reflects the order you created there, but it should.
Okay. All right.
Yeah, it should.
Okay, so what have you found out so far? We won't completely finish this investigation.
All right. So I created an extra table, extra cases, and I got total income and education there. And I was able to create total income versus education one. It doesn't seem very good. I didn't go far. I wasn't able to go far with the formulas and everything.
Okay.
So do you want me to post it into Padlet?
Sure.
Yeah, okay.
And so you're seeing everybody's income. Like you didn't, like I computed median income, you didn't do that.
No, I wasn't able to go that far.
Okay, but what conclusions could you draw from your graph?
Not much.
No?
Can you see it? Yeah.
Yes.
Yeah, it's not very meaningful, obviously, because I wasn't able to calculate anything yet. So
Yeah.
I was playing with CodeUp.
Good.
What did you do?
I want
That's depressing.
Cool. Okay, so one of the things that you might want to know about is in that graph that you have, you can go over to the menu on the right-hand side and see the ruler.
Yes.
You could put the mean on the graph
Okay.
and see if there's a relationship that you can see.
Yes, I did. Now let me paste that one.
Okay.
What year is this data, Tim?
This is 2013.
Oh, I see you even provided that information.
I did. Yes.
Yeah, it's there.
Let's see. Oh, look at that.
Yeah.
Oh, yeah.
Yeah.
So it does look like it actually helps to get more education, which if you're a graduate student is good
Yeah.
news.
Yes. Yeah.
However, as your graph clearly shows, there's also a great deal of variability. And it is possible to earn very little as someone with graduate education. Which, as someone with a graduate education, I can empathize.
Yeah. So I should have created a new income, maybe, right?
Yeah, so you could make a new column in the parent collection in the left-hand table and do a calculation there.
Income.
And Jima, what have you been up to?
So I started out in a very unproductive way. So I started by looking at total income separately, by looking at race in one graph, education in another graph, and gender. And then I broke it up so that I could see the different races, the different genders, and so forth. And then I did box plots and then looked at the means. And then I realized that wasn't really productive because it looked like race and education had an impact. So then I don't think I did it right though. I used a hierarchy and I thought I was finding the meaning of the income based on race and then was graphing that. And it looks like it might be right. And it looks like you could definitely tell that Asians and people that were multiracial and people that were white, it looks like, have a much higher income. And then I was going to do the same thing to look at education because, like I said, when I was looking just at the one variable, even though I did use the color to put education on top of race, but then I was going to do the same thing with education with the table and see what those means looked like.
Okay, cool. Yeah, I am finding that, I'm trying to look at doing calculations for different groups. We're looking at, say, the median income, and I can't get all of my comparisons to show all at the same time.
Mm-hmm.
It's as if I want to sort of take snapshots and keep them and then move on and take a snapshot of another one, and maybe I will compare them later. So anyway, it does look like education, graduate education gives you a lot, and bachelor's gives you a little bit less. It looks like being male gives you more money. It looks like being white or Asian gives you more. Yeah, I don't know if you can see, I have a graph up of mine right now. And there are some things that you can look at. Here is, if I select all the whites, you can see that they're sort of towards the top of each of the groups. Or if I select Asian, it's kind of towards the top. If you are African American, it jumps around, though if you're African American and have a graduate degree, that's pretty good. On the other hand, you can see here in my table, I put in how many people there were. There are only 5 cases. Oops, no, I want graduate degree. Yeah, there are only 5 cases of African Americans, but they do have a median income, and I computed median income of $79,300. The American Indians are not even represented in the bachelor's and graduate group in 1,000 people chosen randomly. Hawaiian Pacific Islanders also similarly. Multiracial, pretty well, although also fairly small numbers.
Mm-hmm.
And interestingly, suppose I wanted to change this graph to sex. If I drag sex into it, if I drag sex to this level, which is where I had it before, now I'm separating by race and sex. Oh, that's really too much. It's too confusing. I'm going to drag race back over to the other side. And if I color it by sex, we actually now have this very clear and clean graph showing how median income increases with education and decreases with X chromosomes.
I think these are really good examples, Tim, of why the hierarchy is so useful, because I know that was one of the things that, like, I had a hard time seeing the value in, but I kept working at it to think about, different data situations. And this is such a clear example of why I would want to use the hierarchy, just like in the example you just showed, where then I could take race out and I could put in gender. I mean, it really makes sense in terms of the types of questions or the activities you would engage people in to really get the full, impact of why the hierarchy is so useful in thinking about the situation.
Yeah, I'm totally with you. I as Bill mentioned at the beginning, I've been around Bill for a long time, and Bill and Cliff Connold, who is another sort of mucky muck he invented Tinkerplots. They've been harping on this thing about hierarchical data organization for years. And, I went along with it. You say, okay, they're really big on that. Fine, I'm happy to consider this. But I never really saw that it would be any use. And it finally got so it was really working well in CODAP about 4 months ago. And so I started using it, and I was playing with one of our data science games, and we might get a chance to look at it at least briefly. And all of a sudden, the light went on for me, because, you look at this situation here where we were able to drag stuff back and forth. We're dynamically reorganizing the way the data is structured. If you were doing this in R or Python, like a big dog, you would be deciding, what do I loop over? And you'd write code, and you'd have this loop. You'd have a loop inside another loop. And in order to change that, it gets really hard. And you can break things really easily, because you have to take the inside loop and stretch it out and take the outside loop and put it in. Students are going to be they're going to have so much trouble with the syntax.
Or even students at the middle grades level. So I work with teachers who, work with those students, and this is very accessible I mean,
Yeah.
it's some work, but it just makes me think about, as a teacher educator who works with students, or teacher educator who works with pre-service or prospective teachers, it really makes me think about the way I design an activity or a task. Like, I really need to change the types of questions that I'm asking in order to make this more useful and powerful. Because I kept saying to Holly Lynn, I'm like, the questions that I keep asking or the tasks I design, like, it's not necessarily like, you know, I'm not seeing why I would need this. But then when I see you or Bill do things, I'm like, this is totally why, you know, this is powerful. And it just makes me think about, I need to change the way I design a task or the way I ask a question in a task to help kids have the opportunity, or teachers have the opportunity, to make use of that kind of thinking. And it can be very powerful, I think, and it can be very accessible to people, like you were pointing out, even just what you'd have to go through to change the code, but even just people that aren't even at the point where they can use something like R. It really hit the light bulb, like, went on for me a while ago, but like, that's one of the things I'm getting as I'm watching you do some things with CodeUp.
Okay. Yeah, I totally, yeah, go ahead.
All of you, I think it's important to make sure that the kids are learning to compare multiple things.
Yes.
Like, they're not comparing female and male heights anymore. I think that was a great question about which one has the biggest impact on education. So there are multiple variables around this. And it is better for them to prepare from middle school level, and it's going to pave the way through multilinear regression.
Yes, and to other data science tasks.
Yeah.
I do imagine that if you are
what is the relationship between education and gender, education and ethnicity, as you were doing? So what is the coefficient between them? So which one has the most powerful? I think it's a great tool.
Yeah, and so you can just see it without ever having to do any linear algebra.
Yeah.
You know, you don't have to think about, oh, what's the within group variability compared to the between. You can see it, and you can just drag stuff around to rearrange it. Is the thing that I love about this. Okay,
I think it's a great example of a data move that has that you reach for. I want to compare the incomes. How can I compute the median incomes? I can regroup here. I can restructure it.
Yeah, and actually that does lead to another insight I've had in the last month, which I should have had maybe 15 years ago, is that, you know, why do we group things? Well, we group in order to compare, and we want to compare all the time. Well, in CODAP, there are now 3 ways to group things. One is you can drag an attribute into the middle and color the points. Another is you can drag an attribute onto the axis and make separate graphs. But now another one is you can drag an attribute to the left and make a new table and change the table. And only in the last one can you compute whatever you want. In the second one, you can maybe put a mean or a median on the graph or make box plots. But if you do the thing in the table, you can make any computation you like.
Yeah.
And that's really interesting, and it gets closer to coding without being coding. And so that's the thing that I like about it. I would love to show you another data set or two. And let's see. Let us do the following. You watch me, and I will show you one, so that way you just get to relax for a little bit. And I'm going to go over here to the one that's part D. This is where I would do, it's called the Blodgett forest. And I have the Blodgett forest data here. And I have separated out, what we have here is data from a forest in California. And so we have temperatures of different kinds and humidity and precipitation and things like that. And we have these data for the year 2000, all year long, every 30 minutes. Okay, so that's over 17,000 cases. And CODAP was moving really slow. And so I extracted 1 month of it. So this is September 16th to October 16th, year 2000. And I'm going to make a graph. And I see there are 1,488 cases. And I want to sort of give you a tour of what kind of data there are here and let you see some of the things we might be able to see. So I have an attribute here called day, which is a decimal day of the year. And so just bear in mind that 260 is September 16th approximately, because it's the 260th day of the year. But I've separated out every day so it's decimal. And I'm going to take the thing that is most salient that we might think about, oh, how hot is it? I'm going to take air temperature and drag it to the vertical axis. So here I have a time series of the air temperature. And you can see, oh, it gets hot in the day and cool at night. Hot in the day, cool at night, hot in the day. And we're in September, and suddenly it got cool. And this is Celsius, and it got cooler still. Okay? And so let's take a look at something. Oh, I'm gonna go like this. I'm gonna stretch it out so we can see a little bit more of how these days go. And now this one here is the soil temperature 5 centimeters down. Okay? I'm gonna put it on the same axis. Oh, here we go. Okay, now the soil temperature is also going up and down, except for this one where it kind of goes down even more. And it's interesting how here, generally the air is hotter than the soil, and here the air is cooler than the soil. And I'm going to zoom in to this part of the graph and see here. Here, the air is hotter than the soil, and the soil is getting hotter. And then the air gets cool, and the soil now is still warmer than the soil. Oh, air is leading the soil in temperature. It's like in the morning, and so this is 276, 277, 0.5 is noon, right? So in the morning, it's getting hotter, and the soil is cool. And then in the afternoon, when it starts getting cooler, the soil is still warm. Well, we've experienced this. If you're outside, the soil sort of changes temperature more slowly and more smoothly than the air. Okay, I'm going to move along here. You're going to see there's this thing that, man, what is going on here? It's getting colder and the temperature is more constant.
That makes no sense.
Well, tell you what, let's add the precipitation. Is it raining any of these times? And now I don't want to put precipitation over here because the precipitation, those are both degrees Celsius. So I'm going to put precipitation on the right-hand side. I'm going to create a new precipitation axis. And now it's gone out to see, so we see everything again. But this is here, and there's no rain, no rain. This is California. It doesn't rain, doesn't rain, doesn't rain, doesn't rain. And here, wait a minute, where is this? I'm going to select this point. And go, okay, it's October 9th. It rains. The first real rain of the fall. And it gets colder, and the temperatures start to get more constant. So I think that's very interesting. We sort of can see, oh, here's this thing that's going on. I want to show you another one just for ducks. We have soil moisture, 10 centimeters down. I'm going to put this on the soil. I'm going to replace temperature with soil moisture.
Ooh.
Okay, so this is soil moisture in percent. this is in the end of summer. Its soil is getting drier and drier and drier and drier and drier. And suddenly it rains and there's a little shelf here and it rains some more. And then here it rains some more. The soil is really wet and it's starting to get drier and drier and drier until the next rain.
It's amazing.
And I think this is extremely cool because here we have this, data set, and there's all this different stuff. Wind speed, PAR, I love this one. This is photosynthetically active radiation. Let me show you what this looks like. And I'm going to get rid of precipitation. We know where it's raining. Remove precipitation. Come on, there we go. And so no clouds, no clouds, no clouds, no clouds. And of course, it's at 0 all night long. And then this one, there must have been clouds this day. And here's where it was raining. There's a bunch of clouds. But there's still some light that gets through. But notice how it's higher here, and it's getting a little bit lower and a little bit lower and a little bit lower and a little bit lower. Oh, it's because we're getting from summer into fall. And the most light that we get is less at noon in the fall than it is in the summer. Because of trigonometry.
Boy, I've played with this data set, Tim, and I've never done these things, and it's really amazing.
Well, and now we think about, how could we find the brightest point during a day? Oh, well, let me make an integer out of the day and drag it to the left. And now I'm going to make it, I could make a new one, the maximum of the photosynthetically active radiation, max of PAR, and graph that. Right? And then can I calculate the latitude of this station from this data? I don't know, maybe. But you can start to see a very computer-y, thinking-y, reorganization-y, data science-y kind of stuff that you can do. And I claim that asking questions like this smells a lot like data science, even if it doesn't require millions and millions of data points. But it does kind of require 1,000 data points in order to get these things. And to have, in this case, 10 or 11 attributes gives us lots of different things to look at and different things to explore.
Lots of room for kids to ask questions. What is going on here?
What the heck is going on? Exactly. I should tell you what some of these, there are VPD is vapor pressure deficit. That's the water pressure below, the partial pressure of water vapor below saturation. And so this is in kilopascals, which is in pressure.
I have no idea what that means.
Okay. Oh, well, if there are more water, it's related to humidity. And an interesting question is, how is it related to humidity? Well, we can explore that with this data. We have soil temperature 5, 10, and 15 centimeters down. What do you think is the qualitative difference between those graphs, 5, 10, and 15 centimeters down for soil temperature? What would you see? Knowing what you know about dirt.
Well, the deeper soil should be cooler, right?
Okay. All right.
Because I would assume that it has something to do with the air temperature.
Okay.
So being further, I don't even know how to explain but I would think it would be
And further from the air. Possibly. Okay, well, let's see. So I'm going to put, soil temperature 5 centimeters down. That's what that looks like. Now I'm going to add 10 centimeters to the same graph. Okay, so what do you notice?
Same pattern?
mm-hmm.
10 centimeters is the red one, 5 is the orange one.
The same pattern?
Yeah, it looks like the same pattern, though it's different in some important ways.
It doesn't swing as wildly.
Yeah, sort of like the top and the bottom. It doesn't go up and down as much.
The maximums are lower than the 5 centimeters.
Yeah, and the minimums are higher.
Yeah.
But that's kind of interesting. Let's put 15 centimeters down here. This really surprised me, Phil. I hope you will enjoy it. Come on, 15 centimeters, drag. There we go.
Whoa.
It's nearly linear.
It's nearly constant.
Yeah, nearly constant, yeah.
It doesn't change as much. Just down another 5 centimeters, at least at this particular spot. So I find that very interesting. And you think about, oh yeah, so the soil is there and it maybe acts as kind of an insulator so that the wide swings of air temperature don't make it down quite as far. Okay, so, this is qualitatively, you could imagine a middle grades class implementing this with actual thermometers and dirt, all the way to a high school physics class, starting to think about thermodynamics and how heat gets transferred. And looking at this and saying, does that really happen in the real world? Yeah, it does. Here it is. Okay. So,
And where were these soil temperatures taken again, Tim?
this is in a forest called the Blodgett Forest, which is in the Coast Ranges of California. It's a station run by the University of California's Forestry Department. And I got these data from 2000, back in about 2002 when they would post them online. And I've looked since then and they have not posted. In fact, they took them all down. And so I have written to the master of the Blodgett Forest to ask them what happened to the data, because we want more recent data. And it would be really cool to get even now there should be a feed of this data.
Oh yeah.
Right? We ought to be able to make a little dashboard where we can see what data are right now and see, is it, I want a webcam and all these numbers. So that I can see what it looks like, and then kids can see that too, and they can record data themselves.
Yeah, because I'm thinking about at the beach, and you dig all the time when you're at the beach, and just how my 2-year-old loves to dig, and so I'm just thinking about just my own experiences with kids and digging, and how this could be really interesting in terms of thinking about other locations. Are there going to be the same types of relationships? And then you're saying, you can actually do some measuring and collecting. But it would be interesting to see if there were, because there's like a Duke Marine Lab close to us on the coast. I wonder if they do these kinds of things.
I wonder, yeah.
Available.
Wouldn't it be great if they had that data? And of course it's summertime and you've been to the beach and you know what it's like, because the top layer of sand is blisteringly hot, right? You want to feel good, you dig down and you can get to relatively cool sand.
And we get caught out in thunderstorms all the time. So just thinking about what it feels like in the soil after it's just even started raining, as compared to, like you're saying, when it's super hot. That made me start thinking about some things.
Yeah, this could be an excellent project as PBL. It's a very hot issue now. I don't know. I'm sure it is. It is very common in Massachusetts and California now. Project-based learning. That could be a great lesson with math and science teacher together.
Tim, I want to draw attention to there being about 8 minutes left.
Okay, good. So here's what I'd like to do now is let's all go to this very last one, which is called Barty. And I'm going to just go to it directly. And I want to show you a couple things and let you know what direction you might go. And then you can play with this on your own time. What we could do. I think we've had a lovely discussion. But here we are in Barty. And you can watch me, or you could do it yourself, but just watch me for a bit, I guess. And I'll show you this map. This is a map of the BART system. And as you can tell, it's in the San Francisco Bay Area, and it's a public transportation rail system. So it's like the DC Metro. In fact, it's exactly like the DC Metro. It's the same age and uses exactly the same technology. And we have here access to data from the year 2015. And I'm going to get some data and explain what we see. So I'm going to click Get Data, and I look down here looking for data, got 19 records. CODAP has the new data. What's up with this? Well, this rectangle here is a plugin. And instead of having the data already in the file like we did before, we're now going out on the web and getting the data. And the data have been gotten by this thing, but you don't see it in the table because there is no table. So I'm going to create a table here in tables, and I'm going to say, you see it says BART data, and it says BART data, don't pick this one, and BART data. And so this is some BART data, and what we see is, like this is April 15th, 2015, Wednesday, hour 0, that's midnight. And it says this so we could actually read it. Wednesday, April 15th, there were 3 riders starting at Embarcadero and getting off at Orinda. And that means that during the entire hour from midnight to 1 a.m., 3 people in total got on at Embarcadero and got off at Orinda. Now, Embarcadero is in downtown San Francisco, and Orinda is in the suburbs. So let's make a graph of this. And I'm going to graph when, which is a date time, and I'm going to put riders on the vertical axis, and we can see this pattern. And so this is going from Embarcadero to Orinda, and I just invite you really quickly to say, what is happening here? What's the story in the graph?
So what is happening between 5 and, is it business hours?
Yeah.
Yeah, 3:30 and.
So like 3:30 and between like 3:30 and 7 p.m., a whole lot of people went from Embarcadero to Orinda.
Yeah.
Why would they do that?
Because they have jobs. Where were they going? Embarcadero to Orinda. Yeah. So there are people who works in Orinda but lives in Embarcadero.
Actually, the other way around, but yes.
Yeah, sorry.
Yeah, that's okay. So they were going from Embarcadero, where they work, back home to Orinda.
Okay.
Okay, and so suppose I go over here and I change this. And
by the way, Orinda is where I live.
That's where Bill lives. That's why he chose it. Suppose I reverse it and have us go from Orinda to Embarcadero. When I collect the data, what will the graph look like?
Or should reverse because they're going from work to home?
What? Okay, so this one is showing us work to home.
This is work to home, so they're going home to work.
Okay, what will the graph look like?
So that the peak time should be seen on the right-hand side.
It should be earlier in the day.
And earlier in the morning, yeah.
Okay, so I'm going to click Get Data and see if you're right. Look at that. So there's the peak in the morning. Oh, you know what? But now all the points are orange. I can't tell them apart. So I'm going to drag start at the first simplest kind of grouping. And now I see the 2 different colors. And I'm make the dots bigger because it's like I'm projecting. Okay. And so, wow. So here's the morning commute. Here's the afternoon commute. Well, that's great. And and so we can look at this. Now, look at this interface here. I can do from Orinda to Embarcadero. I can change which station it is. I can do from Orinda to any station. I could do from any station to Embarcadero. I could do between any two stations. So it says there's too much data to download. How would I make it less? Oh, instead of getting all day, I could choose to get just a subset, just a couple hours. And instead of getting just 1 day, I could get 7 days. Do I want a week or do I want only Wednesdays? Right? I can change what date anywhere in 2015 I'm getting the data from. This data set has over 10 million records.
Wow.
You don't want to download them all because you will bring your computer to its knees. But here in San Francisco, there is this really famous thing called Gay Pride, and it happens sometime in June. Okay? And here's a task, which we will not give you right now, but the task would be, how many people took part to Gay Pride?
Oh, wow.
And the first thing might be, when was Gay Pride? Can you find it just from the data? Yes, you can.
Yeah.
Also, I'm going to say, just for sports fans here, here's our map. The San Francisco Giants have a stadium that's between Embarcadero and Montgomery Street. You can tell when the Giants are playing home games just by looking at the data. The Oakland Athletics have a stadium at Coliseum, and you can do the same thing. Likewise, the Cinco de Mayo and other festivals and things like that, that you could actually study looking just at the BART data. But in order to study it efficiently, you have to be careful about what data you ask for.
So Tim, is this plugin specifically grabbing data from BART, or is it a more general?
I was going to ask.
Well, in this case, the plugin is grabbing data from me.
Oh, from you,
Because
okay.
I got the data from BART and I munged it so that it was more accessible.
Oh, nice.
But ultimately, it would be great if we had plugins that more generally got data from places with feeds that could feed us data.
Yeah.
But until that happens, one of the things we can do is we can try to make interesting data sets accessible.
Right.
So like that NHANES data, which is 11,000, the 2003 health data, that's 11,000 people randomly selected. I've got the entire thing from 2003, but I haven't made a plugin for CODAP yet, but I have it on my website so that you can get files you could upload to CODAP, which is what I did. So.
This was the spatial data that you were talking about.
Sorry, say again?
This was the spatial data for Uber, like
No.
that you were talking about?
I want to get that spatial data. I don't have it yet.
No, you don't have it yet.
Yeah, this is just a train. This is not Uber data, but Uber is telling us that they're going to make the data available, and they haven't yet.
Okay.
I think Uber has been going through some troubles lately.
Yeah, we read that. Yeah.
So anyway, we've come to the end of our time.
Okay.
I appreciate your attention. If I'm easily discoverable on the web, so if you have any questions, you can ask me.
I'll try to find the answer for how many people take the Gay Parade, take the BART in Gay Parade.
Okay.
I'm going to play with the data.
I'll play to you also, and then we can compare.
Yes.
Okay, very good.
Let's do
There's
that.
actually a simpler question, which I can describe to you very quickly, which might be a good stepping stone. If I look at this graph, it looks to me like more people went from Orinda to Embarcadero than from Embarcadero to Orinda.
Mm-hmm.
Well, how would we know? Oh, of course, I can drag things to the left and up. I can do sum of riders. And you will discover that, in fact, more people did go from Orinda to Embarcadero than came back. What happened to them? Oh no, has they been eaten at their place of employment and are not returning? Well, no, there's different things. And when I gave this to high school students, they had all kinds of great answers. They said, oh, they're out clubbing. And they were out so late that they had to take Uber home because BART wasn't running anymore. It was possible. But a question—
But it is a Wednesday night. Let's remember that.
It's a Wednesday night. And so a question might be, is this true every night? Is this true at every station? So you might go to some other nights, other days, and other stations and see whether it's always true.
Okay.
So that's something to do. The other thing I will say is that here on this opening page, we might have some questions and things, but down here at the bottom, there's a feedback form which you can fill in if you like, but you probably don't have to because that's mostly, or if we had a big group. My slides are here and my notes are here, and they have some elliptical instructions. But these are the notes that I use myself to run this session, but it might give you some clues if you're wondering, wait a minute, what did he do then? You could look at that if you wish. Okay. Anyway, I'm so glad you're both here. I'm sorry we didn't have more, but
Yeah. For me, I'm the rookie, so I have a chance to ask questions.
Excellent.
Not boring people, because they probably caught up. So that was my first time. I enjoyed that.
You always would say this to your students, please ask the questions.
Yeah.
You're not boring anyone. Someone else will not know the answer. But you should know that you have license to contact me at any time about any of this, and I would be delighted to help any way I can. And let me actually just let me put this question here. What's your email address? I'll enter it, eepsmedia@gmail.com, so that you can find me. What's you email? What's you email? What's your email? So now you see it there, and you can find me anytime you want, and follow us and see what we're doing. You can read my musings about these issues. .com. I have a blog where I write about this kind of thing occasionally. I am not a religious poster. And so I will occasionally have a flurry of things that I write about data science education or statistics education. Okay.
All right. Thank you very much, Tim. It was wonderful. I'm glad we have a film of it. And Asla and Jima, thank you very much for coming.
Yeah, thank you.
Thank
Okay.
you.
Bye-bye.
Bye. And Bill, are you